Signal, it's time to get going. And I won't be prompt because I'll be honest, I did this session at Ignite US and I struggled to do it in 75 minutes. So I have to try and do it in 60 minutes today, so we'll see how we go. So actually, who am I? What's this session? What are we doing here? What's the purpose of life? So I'm Ben Armstrong, program manager on the Hyper-V team. Come over from Redmond to chat about what we're doing. This is the What's New in Windows Server Hyper-V session. So what this session is about is very specifically about what's new in the Windows Server 2016 Technical Preview 3. And it's about what you can actually go and play with the bits that are out there. It is not a complete overview of everything that'll be in the final release of Windows Server. It's also not like a vision, strategy, why are we doing stuff talk. In fact, I have that talk tomorrow. So tomorrow I'm going to be giving the server virtualization vision and strategy talk, where I'll be talking about where we see the industry going and why we're doing a lot of the things we are doing. Today, I'm just going to be blasting through, showing you the nuts and bolts, what's there and what you can do. One final thing to highlight, I'm talking a lot about Windows Server. I'm going to be showing you all this stuff on Windows Server. Many of these features are available in Windows 10 in the build that's gone out as well. Just FYI. Some other things I'm not going to be talking about a lot. I'll talk about this one a little. Hyper-V on Nano Server. How many people have seen the news about the Nano Server release coming out? Fantastic. Now for the depressing thing, because I know what's going to happen. How many people have actually tried Nano Server? Oh, we have a person. We have a person. Seriously, you really should be trying Nano Server. It's in the TP3 build. It's a really exciting technology, and it's something that we are really hoping that people are going to adopt to run their Hyper-V environments. I'll be talking more about that tomorrow in the virtualization strategy overview. I'm also not going to be talking a lot about containers today. Why? Because, once again, I have a session for that on Friday morning. So Friday morning, I have an entire session where I'm going to be geeking out, talking about containers, talking about how they work, showing you lots of demos on that. I was thinking when I came here that I should have bought a pack of golden sticky stars and said, I'll give out stars to anyone who comes to all 3 of my sessions. So this session is very much focused on what's in Hyper-V, what can you do with Hyper-V. So whenever we look at a new release of Hyper-V, unsurprisingly, one of the big questions we have is what can we do to just continue to up the bar on making cloud great? Whether it's private cloud or public cloud, what can we do to make Hyper-V an awesome platform for running cloud environments on? And there are a number of areas that we looked at in the Server 2016 release. And I'm going to be going through these areas and talking about the features that we've built and hopefully showing you lots of demos that work and don't blow up. This is, by the way, this is my session with the most number of demos, which makes it terrifying as a presenter because there's a statistical odds thing. I'm guaranteed to have at least one demo failure in this session, so we'll see how we go. Security. Security was actually a big area of focus for us. In fact, I'll give you a little inside tip. This is actually something we've been working on for well prior to the 2016 release. There's been a lot of work we've been doing in the kind of underpinnings of Hyper-V to prepare for some of the features that we're finally bringing out in 2016. When we talk to people about cloud computing, and actually this is a good question. How many people here in this room have some workload that's running in a cloud that they don't control, whether it's a hoster or a public cloud? Okay, that's a good number. Now, how many people would say, I could save more money, I could be more efficient if I put more workload than I currently do in someone else's cloud? Okay, a lot of hands there. But when we talk to people, the number one reason why we hear that people aren't using hosters, public cloud services is the issue of trust, is the issue of control, is the issue of, I have sensitive data that I need to ensure is safe and secure. Or even beyond that, I work in an industry where there's regulations and compliance that says that I need to be able to prove that my data is secure and untampered with. So this has been a big area of focus for us. I'm going to show you a couple of demos. Jump across. My demo system has actually finished building, which is fantastic. So the first thing I'm going to bring up is I'm going to bring up a virtual machine that has been configured with a virtual TPM and where the data is fully encrypted and protected. This, unfortunately, takes a couple of seconds the first time. While that's coming up, let me open up the settings to show you. So if you look in the UI, you can actually see that I've created this virtual machine. We've got the security tab, and I've enabled the TPM module on this. And what this does is it allows me to use all the security functionalities of Windows that build on top of this. So if I jump into the virtual machine now, I have so many passwords to type in this session. If I get through it with only mistyping 3 passwords, I'll be happy. So this is a virtual machine that I've set up. If I go into it, the first thing you can see here is my C drive is BitLocker. Now, the great thing about this is this means that, if I give this virtual machine to, either a hoster who's malicious or, the more realistic concern, if I give it to a hoster who I trust and he then gets hacked or compromised in some way and someone gets access to my virtual machine, the data is encrypted and protected. So that's a huge ability to be able to do. Now, I will just say, full disclosure, what I'm showing you here, the nice little setup where I've got, and if I bring up Device Manager, you'll see I have a VTPM in here. This is our evaluation setup. With the TP3 build, you can go in, say, I want to enable TPM. This isn't our full story, iron protection. We do have a much more complicated setup, which involves establishing trust across an entire fabric of a private cloud. If that's interesting to you, then I strongly recommend that you go and do a web search for a phrase called shielded VMs and shielded fabrics, which is the end-to-end story that we're putting together with System Center around this, where you can actually have end-to-end deployment of encrypted, secure virtual machines. But that's the first piece of technology that we've done. The second piece of technology is work to support Secure Boot for Linux virtual machines. So while I bring this up, first a show of hands. How many people here have heard the phrase Secure Boot and understand that it's a thing that we do? Good number. How many people actually know why you should care about Secure Boot? A lot smaller number. So a lot, and I mean, we've done a terrible job of marketing this because Secure Boot is, frankly, an awesome piece of technology. One of the things that we are seeing in the industry and in the world today is a massive uprise in the amount of malicious activity, malicious attacks against systems, and frankly, we're seeing a drastic increase in the complexity and the nature of these attacks. What Secure Boot gives you, if you have a system that supports Secure Boot, and we can run an OS that supports Secure Boot, then we can guarantee you that the kernel has not been compromised. So we can guarantee that this system does not have a rootkit on it, because we're able to measure and attest that the code that's running on here is the code that the vendor gave to you. Now, when we last released 2012 R2, when we first came out with Generation 2 virtual machines, at that stage, we didn't have Linux support for Generation 2 virtual machines, and I had a lot of people questioning us and saying, like, hey, are you being evil Microsoft and not supporting Linux? And we were saying, no, it's not that we're not supporting Linux, it's just that we haven't got this working yet. So I'm actually really happy to be here now, and we now have a large number of Linux distributions that we support in Generation 2 virtual machines, and with 2016, we're actually also providing the same level of protection through Secure Boot. Now, if I come in here, I run this handy little script that I wrote. What that actually just did is it ran a grep command over the device node structure to return the objects in there that says that, yeah, look, secure boot's enabled. What we've done to enable this is, once again, if I go to the security settings, we now allow you to specify security templates for the operating system that you're running. So in the Server 2016 release, we're going to have 2 security templates there. The first one is the Microsoft Windows template, and that's basically the certificate that we sign Windows with. The second one is the Microsoft UEFI Certificate Authority, which is what's used by a number of different Linux distributions. So I'm showing Ubuntu here. You can use SUSE and a number of other distributions that also support this. And this gives you the same level of protection against kernel mode attacks when you're running Linux virtual machines. So let's jump back to my slides. So as I mentioned, we have a larger story here around the VTPM and the protection, which we call our shielded virtual machine story. I'm not going to be able to go into great depth here. This is an entire session in and of itself. So if this is interesting to you, I would encourage you to look up the phrases shielded virtual machine and host guardian service. And we actually have a 70-page white paper out there that tells you how to set up a very secure but fully dynamic cloud environment using this technology. And as I mentioned, we've got the secure boot support for Linux. Right now, it works with Ubuntu and SUSE, which are the 2 distributions who support secure boot on physical hardware. And we're working with other vendors to try and get support there as well. I showed you the UI for turning it on. We also have a PowerShell command for turning it on. So that's some of the things that are coming in 2016 for security. But there's another kind of aspect of security when we look at cloud, and that is the concept of isolation. Now, when we started working on virtualization, one of the key promises of virtualization is that it provides a great level of isolation between your different workloads. It allows you to take workloads from different users, from different trust boundaries, be able to run them on the same piece of hardware. That is fundamental to the promise of virtualization. Now, as the industry is getting more mature and people are doing more and more advanced scenarios, we're kind of upping the bar on isolation. And what we're starting to look at is not only do we want to be able to say, okay, virtual machines from different users, different trust groups shouldn't be able to compromise each other, shouldn't be able to attack each other. We want to be able to say virtual machines from different users should not be able to negatively affect other virtual machines on the same fabric in any way. And this is where we're actually investing a lot of effort in bringing very rich, very extensible quality of service controls to all parts of Hyper-V. So a big area of investment for us has been storage costs in this release. And now, before I get into that detail, let me just highlight something, because this is something I love to talk about, is the importance of performance tuning your private cloud. Unfortunately, I don't have a session on that at this event. I've done entire sessions on performance tuning private clouds before. But there are 2 things that I do want to highlight. The first thing is, if you haven't performance profiled your private cloud, I can tell you now that statistically, you're probably getting about 30% of what you could. That's what we see. Whenever we do engagements with customers and they start with, I haven't profiled my cloud, by the time we're done, we're getting about 3x more performance out of it. And when I talk about isolation, what we actually find is that a lot of people don't realize when they're having virtual machines negatively affecting each other just because they haven't profiled the performance of their system to understand what's expected or not. So honestly, for this whole topic, if you take nothing else away, please start looking at the performance of your private cloud and trying to understand, are you actually getting your money's worth out of it? Now that said, when we're going out and working with customers and looking at the design and the performance of their private cloud, the number one bottleneck that we see today in private cloud deployment is storage bandwidth. By far. It's not CPU. People, most private clouds are running at 20, 30% CPU utilization. Memory, it's kind of close. You know, we see private clouds which are kind of bumping up to the memory. Strangely enough, it's rarely networking, but it is almost always the storage bandwidth. So we're spending a lot of time trying to make sure that people have the ability to control and shape the storage bandwidth used by different virtual machines and different tenants. So in 2012 R2, we introduced for the first time storage QoS. You know, the ability to go in and specify limits and reserves on individual virtual hard drives for virtual machines. And the 2016 Technical Preview 3, we're then extending this capability, and we're allowing you to now do a couple of key things. The first thing is we're allowing you to specify storage QoS policies not on the Hyper-V server, but on the scale-out file server that's backing the storage. And this is actually really important when you start looking at a private cloud deployment where you have 10, 20, 30 Hyper-V servers talking to the same storage backend. It's no good trying to set storage policies on each end node. What you need is you need to be able to go to the storage controller itself and say, OK, here's my end-to-end storage policy. The second thing that we're doing in that is we're allowing you to start specifying shared storage policies and grouped storage policies. So let me show you what that looks like. And full disclosure, in practice, this has been one of my more problematic demos. So we'll see how this goes. The problem I've been having with this demo is that I've got a new hard drive in here, and its I/O performance is not terribly consistent. And so sometimes this demo just runs beautifully, and sometimes it gives me some really weird numbers. So while this is coming up, I'll just explain. I have 2 virtual machines here that I have configured so that they have data drives that are pointed at the same scale-out file server. And what I'm going to be doing is I'm going to be creating contention between these 2 servers. So fire up my nice little fictitious workload here. There we go. So it's now trying to use up all the I/O it can get its hands on. And I'm going to do the same over here. Now, one of the things we've been spending a lot of time looking at is how do we deliver consistent I/O performance? See, that's the bug. Every now and then it goes down to like 200, and I don't know why. I think it's my disk. Anyway, so here I have my 2 virtual machines. They're both slamming the hard drive, significantly shortening the life of my SSD. I have to say this so that when I go for budget requests for more hardware, I can explain why I need new ones. So what I'm going to do is, first thing, I'm going to apply a QoS policy to storage workload 1. And what this is I have a QoS policy on my file server which says any storage object that's assigned to this QoS policy, don't let it go over 2,000 IOPS. So you can see this has dropped down to about 2,000 IOPS, and my other guy has jumped up. It's going like, yeah, there's resource available. But what if these were 2 virtual machines that belong to the same user? What if these were 2 virtual machines that belong to that jerk in engineering who always chews up my bandwidth? And I don't want to have him do that. I want to be able to cap him as a set. So we can actually now do that. I can apply the same QoS policy to both virtual machines. And what this is going to do is it's going to say, whatever is happening in these virtual machines, sum total, they can't use more than 2,000 IOPS. So the user can play around within that cap, can have multiple virtual machines, but sum total can't use more than 2,000 IOPS. So if I come in here as the user and say, OK, I'm going to stop this guy, what you'll see is after a couple of seconds, the first guy's going to jump up and start using the available storage bandwidth. There we go. So this gives a lot more flexibility and control so that the guys who are managing the Hyper-V servers and the storage fabric can have greater control and make sure that different users aren't disrupting and affecting other users. So let's do that. Throw that away and jump back over to my slides. This is, side note, this is really annoying. I can't see the buttons for flicking between the slides and the demo machine. We'll see how that goes. So something I'm not going to demonstrate, but I think this is actually kind of interesting. This is another aspect of isolation that we've been working on with the guys in the Azure Fabric team. Now, this should come as no surprise to anyone here, but unbelievably, there are people out there who buy virtual machines on Azure for no other purpose than trying to attack Microsoft. That's mind-blowing. As I said, biggest surprise in the world. Now, the great thing is, I'm very happy to say, no one's actually managed to succeed in hurting Azure in this way. But man, when they're trying, do they soak up a lot of bandwidth. Like, they cause a lot of weird things. We get people buying virtual machines and running all sorts of hacking tools in them and trying to poke things. And that starts, it doesn't bring the system down, but it does affect performance. So what we've actually done, and this is something that's in the Server 2016 TP3 release, is we now have logic in there that will try and detect malicious activity that we wouldn't expect of a well-behaving operating system. If we see someone going and trying and talking to IOs for devices that aren't there, we will detect that, and we actually, because it may be a legitimate thing, we can't be 100% certain, we actually just throttle back the resource that we give to that virtual machine. And if you see this, we'll put in Hyper-V Manager, we'll say host protection enabled, and you'll get slow performance. The amusing story about this is we weren't planning to put the text in the UI to say host protection enabled. However, we did decide to do this after this functionality actually blew up one of Mark Krasinovich's presentations where he was trying to talk about malware protection. And he had a virtual machine where he'd put a bunch of malware in there to try and demonstrate how you detect it and so on. And we picked it up and we're like, brr. And he's calling us and saying, hey, my demos are all running slow. Like, what's going on? And we're like, well, that's the system working the way it's supposed to. He didn't particularly like that answer. So we've talked about security and isolation. The next thing is availability. This is one of my favorite topics to discuss and work on. It's also one of my least favorite to demo. You'll see why when I get there. But one of the things that I like to say when it comes to server administrators and availability, it's like kids and candy. You can't give them enough. And for the last 4 releases of Hyper-V now, every release I've been able to come up and say, okay, like, here are the things that we've done to keep your virtual machines running more. Like, here are the changes we've made so that you don't have to turn virtual machines off for this. You don't have to turn virtual machines off for that. And Server 2016 is no exception. In fact, I feel like in more than any release in the past, we've done a huge amount of work to keep virtual machines running. So a number of things to discuss. There are 2 features that we've worked on here that we call storage and cluster resiliency. So now for my favorite thing, show of hands. How many people here use Hyper-V clusters? Okay, that makes me happy. A lot of people using Hyper-V clusters. Now for the unhappy question. How many people here have had a situation where Hyper-V clustering let them down and caused them downtime because of a hardware failure and it wasn't pretty? Show of hands? Okay, less hands than I was expecting. So we hear reports from people where there are certain classes of hardware failures that cause clustering and Hyper-V to lose their minds in very bad ways. And the 2 ones that we've heard in particular, the first one is, what happens if I just have a transient network outage? What if, and this is, I love this, because, I have to do a show of hands because this one everyone has seen. It's like, how many people here have had the situation where everything was going fine, life was good in your server room, and then one day, for no reason, the network just went away. Yeah, it just goes away, and then it comes back. And you don't know why, and there's nothing in the logs, and like you can't reproduce it, but it just happens. You know, it's infuriating, but it's a reality of life today, is that we get these big complicated networks and just every now and then something goes wrong and like, brr, you know, and it's gone, and then it comes back. And what we've seen is that when that happens, boy, Hyper-V clustering today does not handle that well. It's usually, the result is usually that the cluster goes insane and thinks that everyone's dead and goes around shooting the people who are alive. This isn't good. This isn't productive. The other thing is, what happens when your storage goes down? And this feature actually excites me most. So I'll be looking forward to demonstrating this. It's a terrible one to demonstrate. But so we've done work on storage resiliency. I'm going to talk more about that while I'm demoing it. And similarly, we've done cluster resiliency, which protects against the network failures. We've also continued to work on shared VHDX. So question, how many people here have actually tried shared VHDX? That's not enough hands. I knew it would be low. How many people have clusters in their environment that aren't Hyper-V clusters? Okay, you all should be using shared VHDX. You all should be. Now, we did shared VHDX in 2012 R2, and I'll be honest, when we released 2012 R2, the state of shared VHDX in 2012 R2 was basically, you could set up a cluster with shared VHDX, and you would get out of the world of LUN management, which, by the way, I have never talked to anyone who said that the thing that excites me most about my job is managing LUNs. So that's a good thing. You want to get out of the world of LUN management. But in 2012 R2, using shared VHDX didn't give you anything else. And we are investing heavily. We want shared VHDX-based guest clusters to be the premium experience for guest clustering. So a couple of things that we're bringing. The first one, this is a huge one, is in 2016, you're going to be able to do host-based agentless backup of guest clusters based on shared VHDX. Prior to 2016, you could do host-based backup of all your standalone virtual machines, but ironically, the things that you care about most that you want to cluster, we couldn't give you a great backup story for, which that makes no sense whatsoever. And so people had to have custom backup solutions for these guest clusters. With 2016, we're building the infrastructure. We're working with all the various backup partners so that when we launch, you're going to be able to get backup from your preferred vendor, point it at a Hyper-V server, and both the standalone servers and the guest clusters using shared VHDX are going to be able to be backed up, zero downtime, without any agents in the guest. The next thing that we're doing is we're adding the ability to do online resize of shared VHDX. Now, for those of you keeping track at home, because usually there's always someone who points this out, what this actually means is when we released 2016, there is now only going to be one thing that you can't do with a shared VHDX guest cluster that you can do with a normal virtual machine, and that's storage migration. And we would love to enable that, but there's only so many hours in the day. So with all that said, let's jump across and do my most hated set of demos. Because whenever I demo availability, I have to demo a system failing, which means that things can get really weird. So let's start with our storage resiliency demo. So I don't want to use this. While this comes up, so what I've got set up for this demo is I have a virtual machine that's configured to use a hard drive that is stored on a scale-out file server. And I'm going to get the system up and running. I'm going to get a workload running. And then I'm going to disconnect the network cable from the scale-out file server to see what happens. So let's run my inspired workload. I'm just a sucker for the pretty graph. So we're going to go ahead and we're going to remove the storage excess. Now, the first thing that you're going to notice is actually kind of nothing's happened. It's kind of weird. It's gone to 0, and nothing's happening. What's going on here? Well, this is actually work that we've done in the past. So when we did the work to support having VHDX stored on SMB volumes, one of the things we were aware of was like, hey, we're now going over the network, like we could have momentary outages. So in 2012, we built in technology that we call resilient file handles. But what resilient file handles do for virtual machines is they basically give you 60 seconds of grace. So if you have a network outage and it comes back in 60 seconds and you're using SMB, scale-out file server, then we'll just buffer up the writes and everything's okay. But once you exceed those 60 seconds, then things go really bad. For most systems, once you've exceeded the 60 seconds, sorry, you're just going to crash. Because what's going to happen is that guest operating system is going to try and write to the disk. We're going to say, the disk is gone, write failed, and the OS is going to just crash. It's going to bug check, because that's what it does. But here you can actually see that I've now timed out the resilient file handle, and I've got this nice little error message down the bottom saying disk encountered critical I/O errors, and the status is paused. And what we did was the first disk write that actually came back from the storage system as saying, like, I can't complete that, we said, right, we're pausing this virtual machine straight away. So this virtual machine is now offline, but it hasn't crashed. Now at this stage, I'm getting support calls. I go, I fix my storage. I find the network cable that someone tripped over, and I plug it back in. And what we'll see is in a couple of seconds, we're going to detect that the storage stack is back up and running, and the virtual machine runs. Fantastic, and my demo worked. So the thing that I like to highlight about this is we have heard the support calls where someone has a storage issue happen at 3 a.m. in the morning. All the VMs crash. They then, frankly, they're then called into work, and they have a terrible next 24, 48 hours while they're trying to piece the system back together. And what started as a like a firmware glitch in a piece of storage that should have been able to be resolved in half an hour ended up being multiple days of hell. With this technology, when you have those storage issues, when you have those outages, it's very easy to recover from, and it's very easy to get back up and running. So, painful demo 1 done. Now for the next painful demo. Let's do the clustering one. So here I have a load cluster set up with 3 nodes, and I have 4 virtual machines configured on it. And what I'm going to do is I'm going to have my script just go ahead and crash the cluster service on one of these virtual machines to simulate a node issue. So that's happened. Now, what you're actually seeing here is we've marked these 2 virtual machines as unmonitored because they were running when we last saw them, and you can actually see them here. They're running. We've also marked the node as isolated. We're saying we can't talk to this node. But if that node comes back, so I'm going to fix the fault, we bring it back in and everything's good. Now, to contrast this to 2012 R2, in 2012 R2, the moment we can't talk to a node, we assume everything's dead, we kill virtual machines, and we fail them over. Now, this is really bad if you just had a momentary network glitch. So in 2016, we've upped the bar significantly on our intelligence here. The first thing that we're doing is we're introducing the behavior that I just showed you, where if a node goes away, we're going to wait for 4 minutes before we go, OK, something's very dead here. Because for most people, like, the cost of turning those VMs off cold, rebooting them, rebuilding them, so on, is so much that it's worth waiting a couple of minutes before you pull the trigger on that. Now that 4 minutes is configurable, but 4 minutes is the default that we settled on after talking to a bunch of customers. The second thing, which I'm not going to demonstrate here today, but I think this is really fascinating, is this is another story. Like most server admins I know have experienced this. There's nothing more destructive in a cluster or in a data center than when you have that piece of hardware that's just on the edge of going. And it works, and then it doesn't work, and it works, and then it doesn't work, and it keeps on coming and going, and it causes a lot of disruption to the system as we're trying to figure out how to run. So we actually have built in a technology that we call cluster node quarantine. And what this means is if we see a single cluster node go into isolated mode and return 3 times in an hour, we say, something's wrong here. And we will put that node into quarantine. And what that means is when it comes back from isolation the 3rd time, we go, OK, you think you're healthy. We're live migrating all these virtual machines off. And we're not putting virtual machine workloads on you until a system administrator comes in and vouches that you're healthy. So I think that's really cool technology. So the third demo I have to do here is the online resize for shared VHDX. So let's do that. So here I have a virtual machine that I've set up. I've got a guest cluster with 2 nodes in it. I'm only bringing up 1 node so I can show you that. I actually have this set up with, it's got a data disk. It's currently got a Quorum drive, but it doesn't have the shared data drive in it. And I've done that for a very specific reason. Let me log in here. I've done that for 2 reasons. And I logged in with the wrong user. Annoying. Let me do that again. Now I'll have my desktop shortcuts. Much nicer. I've done that for 2 reasons. The first one is I just wanted to quickly show we've made a minor UI change here. For anyone who's used shared VHD in 2012 R2, the UI was a bit confusing because we had an option on the VHD to say whether this was a shared VHD or not. We got a lot of user feedback about that being confusing. So what we've done is we've actually just created a new drive type here. So I can say I want to add a shared VHD. Now, one of the things that we actually discovered from that confusing UI was everyone missed the fact that we've always, since day 1, we've always supported hot add and remove of shared VHD because it was just so confusing to do through the UI. But here I have a running virtual machine. I can go ahead, hot add a shared VHD to it, and I can now access it from inside the cluster. So if I go over here, I'll see I have 2 disks. This is my shared VHD. It's a 40 gig CSV volume. I'm going to change its owner node to the guide that I'm logged into, because I'll need that later in the demo. So there we are. And now I'm just going to, I could do this through the UI, but I'm just going to run a PowerShell script that's going to go ahead and resize that from 40 gig to 50 gig. And if I refresh, 50 gig. Fantastic. The volume's still 40 gig, because I need to go in and use disk management to extend the partition. But if I come in here, even though this is a CSV volume on a cluster, I can still come in here, expand the partition, and there we go. And this just makes it a lot easier to respond to user requests. You know, if people have workloads, they find that they're running out of space, you no longer have to take a system down in order to respond to that request. So that's a bunch of storage availability stuff. But beyond that, there's then, as I said, we will do this every release until there is nothing left to do. There is a bunch of stuff that we have now allowed you to do while a virtual machine is running that you used to have to turn the virtual machine off for. The first one, we now allow you to add a virtual hard drive to a virtual machine that's replicating, and replication keeps on going. We allow you to add and remove hard drives from the replication set. So if you have a virtual machine that's replicating, you need to add data, add more storage to it, you can now do that without affecting replication at any stage. We've added the ability to do runtime memory resize even if you're not using dynamic memory. This is really handy. We love dynamic memory. I love it personally. It's one of the features I worked on. But we also understand that there are lots of workloads that people have where they need to size the memory statically. This doesn't mean that they don't want the flexibility to adjust if they got things wrong. So we now enable that. We also support hot add and remove of network adapters. So I'm going to demo a bunch of this. I am running tight on time, so I'm going to skip over the add and remove of replica demo. Apologies. It's fairly straightforward to do. Let me demonstrate the hot add and remove features. So this is a couple of things to be aware of. For the hot add and remove of network adapter, this is for any generation 2 virtual machine. For the online resize of memory, this is only for Windows 10 or Windows 2016 guests. So here I have a generation 2 virtual machine. Let me find it over here. Configured with 2 gig of RAM. Now, one of the little things that I actually really like here is even for virtual machines that don't have dynamic memory enabled, we now show you the memory demand. This is great if you're just trying to understand if you've sized your virtual machines correctly, how they're using memory, so on. But first things first, let me pull up network connections. This guy's currently set up with a single network adapter. And I can just bring up settings, and I can add a network adapter. And say ignite. And in fact, I can go crazy and add a bunch of them. This is actually really fun. We found some bugs in Windows because while doing this, because you can't normally add 5 network adapters at exactly the same time to a physical computer. So let's see how this goes. So it's going to go through, throw those all in, and Windows is going to have a little panic while a whole bunch of devices turn up. And yep, there we go. And it's happily chewing up IP addresses from my DHCP server. But nice and easy. And then once again, if I realize that 6 network adapters is a bit silly, I can go in and remove all of these. Yep, and there we go, all gone. Nice and simple. And similar story with memory. So if I come over here, bring up Task Manager, you can see I've got 2 gig of RAM. I can come in here and say, I want to give it a little bit more. I have to be careful. I'm actually almost running out of memory. So if I put that too high, it fails. So 2.3 gig of RAM, or I can say, I'm running low on memory. I need a bunch back, please. And 1 gig of RAM. And it failed. This is actually nice. You'll see this is, if you ask us to remove more memory than the guest operating system is willing to give up, we will remove as much as we can and give you a message saying we couldn't. So 1.5 gig. If I try again, we usually succeed the second time. There we go. So 1.3 gig. So yay, I've freed up some memory from my system. So that's nice and simple. The next thing, this is a big thing that we've added, is the support for rolling cluster upgrade. We've been working on addressing, making upgrade easier for Windows Server and for Hyper-V for a while now. The 2016 release is a big one for us because this has been kind of the goal that we've been working towards, is that in 2016, you can now have, do a cluster upgrade with no new hardware required, no downtime for your virtual machines, the ability to roll back safely, and providing protection the whole way through. And basically what we enable you to do is you can take an existing 2012 R2 cluster, and you can 1 node at a time take it out of the cluster, upgrade it to 2016, add it back to the cluster. The entire cluster continues to run as though it were a 2012 R2 cluster. And while it's in this mode, you can live migrate virtual machines back and forth. You can use all the virtual machine functionality, and it continues to work. And you can actually fully upgrade a cluster to 2016 and wait for a little bit. And if you have an issue, you can roll it all the way back to 2012 R2 without ever having to turn virtual machines off. What we do have, though, is that if you want to add access new features that are in 2016, you have to upgrade the cluster. And there's a cluster functional level that when you change that, it's a point of no return, because now we start turning on new features. So we have the same concepts in Hyper-V to support this. So this has been a huge amount of work for us. In the previous releases of Hyper-V, if you bought a virtual machine into management by Hyper-V, we would automatically upgrade the virtual machine configuration, and there was no way to roll it back. In Windows 10 and in the Technical Preview 3, now when you bring virtual machines in, we don't automatically upgrade them. We keep them at the version that they were at. And you can continue to use them, and you can use all the functionality that you've used, but we keep it compatible. And we keep everything compatible. So you can take checkpoints, you can do save states, you can change settings, you can do whatever you want, and you can still move that virtual machine back to a previous version. Then, if you get to the point in time where you're like, OK, I want to use features that are only available in 2016, you can do a manual upgrade process. So this is all about giving people flexibility and control. So quick demo of this. I have my inspired old virtual machine here. You can actually see we now have configuration version 5.0. This is the version that was used by 2012 and 2012 R2. And this virtual machine runs just fine. Perfectly happy. And I can come in here and I can mess around with settings and I can do what I want with the virtual machine, assuming the settings come up. I think I just had my demo glitch. Oh, no, there we go. So I can come in here, I can change settings. But the great thing is, at this stage, everything is fully compatible. So if I need to move this to a 2012 R2 server, that all works fine. Let me just jump in. Yay, first password wrong. There we go. So here's my virtual machine. It's running fine. And I can use this. And a common question we get is like, well, how long do you support virtual machines in this mode? For as long as you need them to. Like, we're not putting any support statement out there saying that you need to upgrade. But if I want to upgrade this virtual machine, what we need to do is we need to shut it down, and we need to upgrade the version. Only that. Let's do that again. So we're going to shut it down. And you can do this through the UI or through PowerShell. Either way, you get a nice, scary confirmation prompt because this isn't a reversible operation. Once it's upgraded, you can't go back. But the upgrade operation, as you can see, really fast and simple. My virtual machine's now up and running, and all the functionality is there. I'm not going to wait for that to connect because we're running short on time. So now for my favorite section of this session, what I call the operational improvements. Now, this is the stuff that we've done, not because it connects to some big overarching thing, but just because it irritates people on a daily basis. You know, there are the things that we do because, like, wow, there's a big strategy and a big direction, and then there are the things that we do because we hear from users that, like, hey, on a daily basis, while I'm doing blah, it's really annoying. So I'm going to blast through this. The first one is a feature I'm really excited about called production checkpoints. So another show of hands point in time. How many people here use VM checkpoints in Hyper-V? Should hope it's everyone, because great feature. How many people here use VM checkpoints in Hyper-V on production servers? Yeah. Yeah, you know we've always documented that's not supported. Like since day one. The great story here is when we released the first version of Hyper-V, we knew that checkpoints weren't great for production environments. And we're like, it's OK. We're going to document everywhere that they're just for dev test environments. They're not for production environments. And 6 months after we released the first release of Hyper-V, our #1 support call generator was people shooting themselves in the foot using checkpoints in production environments. Fantastic. Let me tell you, if you work on a product at Microsoft and you create a #1 support call generator, you get to meet the VPs. It's not a fun way to meet VPs, but that gets to happen. So over the years, we've been working on making checkpoints suitable for production environments. And in 2016, it's going to be the first time that we come out and say, these are supported for production. And the big difference here is that we use VSS to create the checkpoint instead of safe state. And this means that any software that supports being backed up and restored on Windows is now supported with checkpointing. The next one is, honestly, this is possibly my favorite feature in the release, is a feature that we've done called PowerShell Direct. And PowerShell Direct allows you to use PowerShell to connect to and interact with a copy of Windows inside a virtual machine without having to have networking working. It's like magic. It's crazy the amount of things you can automate and you can build with it. It's a very cool technology. And we're doing this by allowing you to do PowerShell remoting directly over our VM bus channel. So there's zero configuration for the end user. You just sit down at a PowerShell command prompt, say, I want to run this command in that virtual machine, and it works. So it's a really cool feature. The next one, I'm going to demo this. We've done a lot of work with the storage team to start doing REFS acceleration of storage operations. And the final thing is some Hyper-V and Hyper-V Manager and PowerShell improvements. I'm so running out of time, so let's jump over to demos. And I want to show some of these to you. So let's go through these in order. So the first thing I want to show you is production checkpoints. Let's bring up this virtual machine. So we now have a number of settings available for checkpoints. I have no idea why. Actually, I do know why the settings UI is taking so long to take up, and it's really annoying. Basically, I have a name resolution issue on this box, and it's trying to resolve the name. Let's go here. OK. So this virtual machine is currently set up to take standard checkpoints. And standard checkpoints are the checkpoints that you know and love as they've always existed. So if I come in here, Notepad, foo, text, yes. Hello, New Zealand. And I can take a checkpoint, standard. And what we've actually just done is we've captured all the disk, but also all the memory state of that virtual machine. So if I revert to this checkpoint now, what we're going to see is we're going to see that the virtual machine is in exactly the state it was when I took the checkpoint. So there, I've got Notepad up. It's the way it was. Now, how are things different with production checkpoints? Well, make a note. But this time, first, I'm going to go in. I'm going to say, instead of using standard checkpoints, can we use production checkpoints? And having done that, the experience is actually exactly the same. I take a checkpoint, I name it, it appears in the UI, I do the checkpoint operations. I do get this nice little message that says, hey, we did something a little different here. Because now, if I revert to that checkpoint, what we'll see is that all my data has been saved, but not the state of the running application. Because if you think about it in a server environment, if I take a checkpoint of my SQL server, from my Exchange server, of whatever, I'm not doing it to capture the state of all the clients that are currently connected. I'm usually doing it because I'm about to try something risky, and I want to have a safe point to go back to. So now this is here. If I have a look, you'll see that my text file is there, all my data was saved, the experience is the same, only this, to the application inside the virtual machine, it feels like, oh, they took a backup and they restored the backup. So it's completely supported in production environments. So that's that. Now for PowerShell Direct. This is a really fun one. Find my command. So this is actually a demo script that was put together by someone on my team. And what this is actually going to do is I'm going to have this virtual machine up and running, and you're going to see a bunch of stuff happening inside the virtual machine. But it's all being orchestrated from PowerShell inside the host operating system without going over the network at all. So here we go. So we've got nothing in here. Actually, I need to have. Now, I am going to be launching a script inside the virtual machine. It doesn't actually do anything other than report status on what's going on with the system. So I'm going to start this, and the first thing it's going to do is it's going to copy a file into the virtual machine for me, the Ignite listener, and I'm going to start that. And what this listener is doing now is it's ready to go so that as I start doing things from the host using PowerShell, we're going to see it happening. So first thing we're doing is we're installing IIS in the host. Sorry, in the virtual machine from the host. So on the left here, this is all code that's running in the host without having to go over the network. And you can see here we're enabling IIS, and shortly you're going to see our listener script inside the guest say like, hey, IIS has just been enabled. Now, this becomes immensely powerful for doing automation of build and test environments. This is something that we use heavily on the team because now it becomes very easy to go like, okay, I need to build 5 virtual machines with the following configurations, and you can have a single script that goes through and runs all of it without taking any dependency on the network. So you can see IIS has been enabled. The management tools are being installed. We're setting up a website. And we are good to go. If I grab this IP address with any luck, let's see if it comes up. This is the awkward point. I know it takes a couple of seconds. I'm going to, there we go, finally. So we have the website. But the great thing is that this didn't take any dependency on networking to set up. So there we go. So the final thing I'm going to demonstrate, and then I'm going to have to wrap it up. This is my last demo. I do have a couple of slides, but we're running out of time. So I'd recommend that you look through them, is the REFS improvements. Only I started the wrong script. That's annoying. Let me jump through this. So while I'm getting this fixed up because I hit the wrong thing. So I like to do this show of hands. Who here has created a fixed size VHD that's over 1 terabyte in size? Anyone? We've got a couple of hands. Over 2 terabytes? We've got a couple of hands. How long did it take? Not that long? Because it usually, one of the biggest complaints we hear is how long it takes to create fixed size VHDs. Because people like to create fixed size VHDs because they give a level of protection and guarantee. But when you create a fixed size VHD, we go through and we zero it all out. It's trying to get back to my demo script. Okay, I'm going to have to kill this and restart this. So what we've actually done in the 2016 release is we've worked with the file storage team to start enabling some new scenarios using REFS and using REFS acceleration. And there are two scenarios we've enabled in particular. The first one is instantaneous creation of fixed VHDs. The second one is instantaneous merging of virtual hard drives. So if this comes up, hopefully we'll be, there we go. Now this time I want to hit I, not R. Hit the wrong letter. So this is, for this demo, I have a very fancy old spinning hard drive attached so that it's nice and slow. So the first thing I'm going to do is I'm going to create a 1 gig fixed VHD on an NTFS partition. And this is the experience that most people have today. You say, I want to create a fixed VHD, and you then have to sit there and wait while we go out. And what we're actually doing is we are going through and one block at a time zeroing out the data. Because NTFS doesn't have any awareness of concepts like virtual hard drives. It's not very intelligent about these things. So on this drive, this is going to take about 30, 40 seconds. Now, personally, the largest fixed-size drive I've had to create was a 5 terabyte drive, and it took about 22 hours. It was not fun, and it was quite boring. So you can see 33 seconds to create a 1 gigabyte drive. If I create the same thing on REFS, 1 second. And in fact, if I create a 50 gig fixed VHD, 1 second. Because REFS has the intelligence where we can go to it and say, we want a 50 gig file that's full of zeros. And it will go, OK, I'll take care of that for you. And it handles that without us having to manually go through and do that. But to me, the really fun one is actually merging disks. So if you use checkpointing, if you use backup, if you use Hyper-V replica, you'll know that we have this pattern where we create differencing disks that allow you to capture the changes, but then they have to be merged back in. And that can be quite a heavy operation, and it takes a lot of time, but more than that, it uses a lot of I/O. It thrashes the system a lot. And so we've done some great work here where, OK, I just merged in. By the way, that was about a 500 meg diff disk that I merged in. It took 29 seconds. If I do the same files on REFS, it gives me an error. OK, that didn't work. It would have taken about a second. I'll have to figure out why that gave me an error. But it takes about a second. And the reason why is, unlike NTFS, once again, REFS has the intelligence that we can actually go to it and say, hey, these two files are actually differencing files. Can you give us a file description that is the union of these two files? So the great thing there is not only is it fast, but it does it with zero block copy. So unfortunately, I do have a bunch of slides. That is the last of the demos. I do have a bunch of slides to talk about. We've made changes to cross-version management, how we change VM servicing. Also some changes that we've made to how the configuration is stored, how power management works. And the final thing that I do want to point out for people who use remote effects is that we have enhancements in remote effects, specifically extending the support for OpenGL and adding remote effects support for Generation 2 virtual machines. So I am 3 minutes over time. I do appreciate that you've all hung out here. I hope this was useful for you. I hope that you do go and play with the TP3 release. Give us feedback about what's working and what isn't. I'm going to be in the hub this afternoon at the happy hour. Please come and find me. Talk to me about what you're doing with Hyper-V, what is and isn't working. And again, thank you all.